In this video, I'm going to discuss kinetic molecular theory. And we've already been introduced to this a little bit as we've been talking about phase changes and energy of particles and different states of matter. So the word kinetic refers to motion, and kinetic energy is the energy an object has because it's moving around. So when we think about kinetic theory states that the tiny little particles that make up any matter are in constant motion. So we know as a solid, we talked about the particles vibrating in place, right? So they're not stationary altogether. They do have some motion, and the more motion they have, the more energy they have, and therefore they change from one state of matter to another. So solids have very little energy and they're just vibrating. Liquids have greater energy and they're flowing past one another, and gases have the most energy and they're sort of bouncing all around. So the average kinetic energy of particles that are in a substance is actually what the temperature of that substance is. So that is why it is related to what the state of matter is. We know as we heat something up or we add more energy to it, the temperature increases and the state of matter increases. So temperature is actually the measure of the average kinetic energy of all the particles in a substance. And we have three different temperature scales. We have Celsius and Fahrenheit, which are both degrees, but the absolute temperature scale is the Kelvin temperature scale. And that temperature scale is directly proportional to the average kinetic energy. So we have this idea of absolute zero. Because the motion of particles defines the temperature, the temperature at which motion of particles ceases, so theoretically stops, we've never been able to achieve this, is absolute zero, and that is what 0 Kelvin is. That temperature is negative 273 degrees Celsius. So we've never been able to reach this absolute zero where we've made particles completely stop, but we've gotten pretty darn close. So we're going to talk about kinetic theory in terms of gases, and there's three assumptions that are made in terms of gases, and I will relate that as we talk in later videos about pressure and as we move into talking about gas laws. So just note that there are three different assumptions when we talk about kinetic theory. So number one is that a gas is composed of particles, usually molecules or atoms. And we say that these particles sort of act like small hard spheres, so almost like, imagine like, kind of like bouncy balls. And they have a very small or insignificant volume, and they're relatively far apart from one another, so they're bouncing around the container or wherever they're located. And so there is no attraction or repulsion between the particles whatsoever. Now, is this true? No, but these are the assumptions that we have to make in order to understand the nature of gases and how they behave. So number two, the particles in the gas move rapidly and are in constant random motion. So they are just bouncing all around a container. And we saw this when we looked at the simulation before, when I heated up the neon and you could see all the particles bouncing around. So they move in straight paths until they collide with another object and then they bounce off that object. So the third assumption is that collisions are perfectly elastic. And if you take physics, we'll learn a lot more about this, but perfectly elastic means that there's no loss of kinetic energy when they collide. So they're just bouncing around, and the total kinetic energy and the average kinetic energy of all the particles in that gas at that temperature are going to remain constant. So just keep in mind that these are the three assumptions about kinetic molecular theory for gases. In the next video, we'll relate this to pressure and boiling point.